In this section, we're going to take a look at a couple of different miscellaneous topics that don't really belong in their own section per se. So these are all going to be very small little topics, just things you need to be aware of, but not stuff that's so important that we need to have many different videos on each one. In this video in particular, we're going to take a look at a new keyword called distinct. Distinct is always going to be placed inside of a select clause, and we're going to place it right after that select keyword. So you're going to see the words select distinct. Distinct is going to give you a list of all the different unique values inside of a column. So for example, if we wanted to find all the unique departments inside of our products table, we could write select distinct department from products. That would give us a list of just the distinct or unique departments inside this table. So if I take this example right here, we would take a look at the first value, toys, and we would remove any duplicates of toys. So these two down here, we'd drop. Next up, we'd take a look at outdoors, and we'd remove any duplicates of it. And then industrial, and remove any duplicates of that as well. And so we end up with just the unique values, toys, outdoors, and industrial. These are the only values that we're going to have access to inside of this distinct or the select clause. So we cannot try to print out, say, the price for each of these. We're only going to see just these values by themselves. Let's take a look at a quick example of this. So back over here, we'll do a select distinct department from products and run that. So now in this list right here, we should only see unique values. We should not ever see a duplicate of, say, tools or toys or outdoors or so on. One very good use of this distinct keyword is to print out the number of unique values we have. To do so, we would wrap distinct department with a count aggregate function. We could then run that, and it will tell us the number of unique departments we have inside of our products table. So this is super useful anytime that you want to start to explore a data set and get an idea of how many, unique values you have. One thing you might notice right away is that distinct is kind of similar to group by, because they are both all about somehow taking a look at a column and removing duplicate records. In truth, you can use distinct or you can use group by in place of distinct, but you cannot use distinct in place of group by. Only group by can make use of aggregate functions to take a look at values inside of each of those different groups. So it's a lot more important for you to understand how group by works in general than it is for you to understand how distinct works. Now, if we ever want to find multiple different unique values, like let's say unique values across different columns, we could do a select distinct department and name. This will give us a list of all the unique combinations of these two columns. So it's going to find every unique combination of department and name put together. So if we run that, we're going to see way more records. So inside this list, we might see kids multiple times. There's a duplicate right there, but we will never see a row where we have the same department and the same name. Every single row, if we take the two values and join them together, will always be unique. Now this is definitely useful, but there is a downside to it. If we do a distinct over two or more different columns, we can no longer do a count on it. So just a funny little restriction there. If we try to run this, we'll get an error like so. We can only do a count when we are finding distinct over one single column. But as soon as we add in that second column, or even another, nope, can't do a count anymore. All right, so that's distinct. Again, it's all about finding unique values inside of a column. It is functionally quite similar to group by, but group by is a little bit more powerful because it allows us to apply those aggregate functions to each interior group. That's pretty much it on distinct. Let's take a pause here and continue in just a moment. We just took a look at distinct, but let's get some exercise or practice with it right away. In this exercise, our goal is to print out the number of unique phone manufacturers. So we need to take a look at the manufacturer column and then somehow print out the number of unique values inside of here. The correct answer should probably be something like 4, because I see Nokia, Apple, Samsung, and Motorola. So those are 4 unique manufacturers. So go ahead and try to put a query together. We'll take a look at a solution in just a moment. The solution to this exercise is very similar to the SQL that we looked at in a video just a moment ago. So all we have to do here is select count, and then inside of a set of parentheses, distinct manufacturer from phones. And that's pretty much it. So we're going to first find a list of all the unique values of manufacturer. We're then going to count up the number of rows on that column or the number on that list. And that's it. We're going to print out the value. Let's check our solution and just make sure we get the correct result. Yep, looks good. In this video, we're going to take a look at a little function that is built into Postgres that allows us to select the greatest value out of a list of values. Let's start off first with a very quick example. I'm going to write in select greatest. I'm going to call it with like a function, and I'll put in some list of values here. So maybe 20, 10, and 30. The greatest function is going to take a look at this list of values and return the greatest or the largest value. In this case, it would be 30. So if I run this, I end up with a result of 30. If we change the 20 into a 200, now we get back 200 because now that is the greatest value. So at just a glance, greatest is pretty simple and straightforward. But you might be curious where we would use something like this. Well, we can very easily imagine how we might make use of greatest if we consider the following question. Let's say that we want to compute the cost to ship each item inside of our products table. And maybe the rule for calculating the shipping cost is that we have to find the greatest or the maximum of two different values. So shipping an item is going to cost the greater of the product's weight times $2 or 30. So at a minimum, it is $30. Otherwise, it might be the weight times 2 if it is greater than 30. So we can kind of imagine the calculation that would go on here. We kind of want to take our weight column and run some calculation on it. Maybe we would call this something like cost to ship. We would then multiply all these different values by $2, and that would give us our cost to ship. We would end up with 6, 32, 12, 46, 20, 22, and 4. Then, if any of these different values are less than 30, we're going to take $30 instead. So 6 is less than 30, so we go up to 30. 32 is greater than 30, so we're going to stick with 32. We go to 30, 30, 30, and 30. So that would be how we would calculate our cost to ship. Let's try making use of the greatest function to calculate this cost to ship column for us. All right, so back over here, I'll do a select name and weight, and then I'll apply the greatest function. There we go. And we want to find the greatest of $30 or 2 times a product's weight. And then we'll do a from products like so. So as usual, we're going to take all the different rows from products, and then we're going to run this select clause on every single row. So for every single row, we're going to print out the name, the weight, and the greatest of 30 and 2 times that row's weight. Let's run that and see what happens. Okay, so now we've got 3, that would get rounded up to 30. 16, that's going to be $32 to ship. The 6 right there, well, that would be $12 to ship. That's less than 30, so it would round it up to 30, and so on. You can go on down the list. That's pretty much it for weight, or excuse me, for greatest. I was looking at the word weight, but that's how we would make use of that function. All right, now that we've seen greatest, quick pause here, continue in just a moment. Just like greatest, we have access to another function that allows us to find the least value out of a list of values. So for example, we could do a select least and then put in some number of values inside of here. Let's try about 1, 20, 50, and 100. If we run that, we'll then be given the least value out of that list. In this case, it's 1. If we increase 1 up to, say, 1,000, now the least value is 20. So if we run this again, sure enough, we get 20 back. You can think of least as being effectively the exact opposite of greatest. Where would we make use of least? Well, let's take a look at a very quick example. Let's say that all of our different products are on sale, and the rule to calculate the sale price of a product is the product's price times 0.5 or $400. So the least of those two values. In some cases, some of these different products might end up costing more money, but whatever, this is a really weird sale. So to calculate the new price of all these different products, we could do something like select name and price, and then the least of the item's price times 0.5 and 300. I said 300, right? Oh, 400. There we go. Let's run that. And now we can see all these new prices. So we get price, and here's the sale price. So in this case, 876 divided by 2 or multiplied by 1/2 would be something like 400 and what, 35.5. Well, that's greater than 400, so we end up with the least of those two values, which in this case is 400. Well, that's pretty much it. That is greatest and least. These are definitely two functions where you're going to know that you need it when you need it. And for right now, it's really just important that you understand that these two functions exist. Okay, so that's it. Let's take a pause here and move on in just a moment. Let's take a look at another new keyword. So for this new keyword, we're going to first start off with a little problem here. I want to try to print each product's name and its price. And then in addition to those two columns, I also want to print a description of the price. So the rules for printing out the description of the price are going to be if the price is greater than 600, I want to print out high. If it's greater than 300, medium. Otherwise, I want to just print cheap. So we need to generate a new column somehow. We'll have this describe the price in some way. And then for every single row, we're going to look at the value of price and print out a different string based upon this number. For this first row, we've got a price of 876. That is greater than 600, so I would put I here. The next one is less than 600, but greater than 300, so we would do a medium. And then the next one is 10, which is less than 600 and 300, so we'd put in cheap. And then we would repeat that for all the rest of these rows. We'd have medium, high, and cheap. That's the goal. So to do so, we're going to use a new keyword called case. Let's take a look at how to use case back over here. So we're going to do a select. I'm going to give myself a little bit of space here because anytime we make use of case, we end up needing a couple of extra lines. So right after select, I'm going to indent and then add in name and price as two columns I want to print out. And then we're going to write in our case statement. So we're going to put in the case keyword. We'll put in end. And then right in between, we're going to put in a couple of different comparisons. So we're going to say if, or I should say when, some condition is true. So in this case, we'll say when price is greater than 600, then I want to put in high. When price is greater than 300, then I want to put in medium. And otherwise, if we don't satisfy either of these checks right here, I want to just default to using cheap. We can then put a from products like so, and let's run this. Now we can take a look at the result very quickly. You'll see that whenever we have a price greater than 600, we get high. Anything greater than 300 gets a medium, and 10, or I should say less than 300, gets a cheap. So we can make use of a case to take a look at one or more columns inside of a row. We can inspect their values. We can run any kind of comparison inside of here we want to run. If this comparison results in true, then we're going to exit the case early and just print out the value on the other side of the then. That's pretty much it for a case statement. Now for the actual comparison we put inside of here, we could place any kind of comparison that we would normally put inside of a where. So like I said, we could do two or more columns. We could say, hey, let's take a look at the price times the weight. Maybe take a look at that price to weight ratio. We could do the price divided by the weight. That would actually be the ratio. Whatever else we want to do. All we have to do is make sure that we ultimately return a comparison inside this when. It is not required to have the else in there, so we could take the else out. But if we ever have a row that does not satisfy either of these whens, then we're going to end up with a default value of null instead. So usually you will want to have an else in there to handle the case that you don't satisfy either of these statements. So in this case, we will have a default of else cheap. All right, so that's pretty much it for case. Now, to be honest with you, case is something we're not going to see terribly often, because very often, rather than doing kind of any comparison like this inside of at the database level, very frequently we will instead want to do a comparison at our code level. So on our actual server or whatever is running or sending some queries to our database. So in other words, it's more often that our actual application would take a look at the price values and decide whether we want to print out high, medium, or cheap. So it's important for you to understand case, just know that it exists, but it's not something that you're going to be making use of terribly often.